Welcome. In this video, we will explore the fascinating intersection of big data and artificial intelligence. We will delve into how AI leverages the immense power of big data to reshape and transform our digital world, opening up new possibilities and innovations. Get ready to understand how these two powerful forces are working together to drive the future. Let's begin by understanding big data. Big data refers to extremely large datasets that are too complex and vast to be dealt with by traditional data processing methods. It is characterized by the 5 V's: volume, velocity, variety, veracity, and value. Big data involves massive volumes of both structured and unstructured data, generated and processed in real time, in multiple data formats, from a multitude of sources. Big data comes in various forms. Firstly, there is structured data. This is organized data that fits neatly into predefined fields, making it easily searchable and analyzable. Examples include SQL databases, spreadsheets, and CSV files. Secondly, there is unstructured data. This is the opposite. This is the data that doesn't conform to a specific format or structure, making it more challenging to process. Examples of unstructured data include text documents, images, videos, and social media posts. Thirdly, there is semi-structured data, which has some organizational properties but doesn't conform to strict database standards. Examples of semi-structured data include JSON files, XML documents, and email messages. To effectively manage big data, it goes through a structured processing pipeline. The first step is data collection, which involves gathering data from various sources, including Internet of Things devices, social media, logs, and databases. This can be represented as source going into Kafka.collect with a stream function. Next is data storage, which involves storing the collected data in distributed systems like Hadoop or cloud storage solutions. This can be represented as data.store, with Hadoop.distributed as a function. Finally, there is data processing, which includes cleaning, transforming, and preparing the data for analysis using tools like Spark. This can be represented as Spark.process, with data.clean as a function. There are various tools and technologies available for working with big data. These can be broadly classified into tools for storage and processing, and tools for analytics and visualization. Under storage and processing, there is Hadoop, a distributed storage and processing framework. There is Apache Spark, a fast data processing engine. And there is MongoDB, a NoSQL database solution. Under analytics and visualization, there is Tableau, a data visualization platform. There is Power BI, a business analytics service. And there is Jupyter, used for interactive data analysis. Artificial intelligence algorithms leverage big data to train models and make predictions. This enables efficient processing and decision-making. Let's look at a simple example of how machine learning models process big data. First, we load and pre-process the big data. Here is some code that shows how it is done. We import train test split from scikit-learn and pandas as PD. Then we load big data from distributed storage, which can be done using data equals pd.read_csv, with big_data.csv as a parameter. Next, we pre-process and prepare the data for the AI model. We create X by dropping the target axis equals 1, and create Y equals data target. Finally, we split the data for training using x_train, x_test, train_test_split, xy test size equals 0.2. The integration of AI and big data has led to transformative applications across various industries. In healthcare analytics, it enables predictive diagnosis using patient history and symptoms, as well as treatment optimization through outcome analysis, achieving accuracy of up to 95% in early disease detection. In financial services, it facilitates real-time fraud detection in transactions and automated risk assessment and credit scoring, leading to a detection rate of 99.9% for fraudulent transactions. Despite its immense potential, there are several challenges in the realm of big data and AI. One major challenge is data quality and consistency. It is vital to ensure accuracy and consistency across large, diverse data sets from multiple sources. Another challenge is processing power. Managing computational resources for processing massive data sets efficiently requires significant infrastructure. Furthermore, privacy and security are critical concerns. It is important to protect sensitive information while maintaining data utility for AI training. The landscape of big data and AI has evolved significantly over time. In the past, traditional data processing faced limited data storage and processing capabilities, relying on manual analysis and basic statistical methods. In the present, advanced analytics leverage cloud computing and distributed systems, enabling real-time processing of massive datasets with machine learning algorithms. Looking ahead to the future, AI-driven innovation promises autonomous systems and advanced AI models processing data at unprecedented scales with quantum computing integration. In conclusion, here are some key takeaways. Big data and AI continue to evolve together, creating more powerful and efficient solutions. This partnership has a transformative impact, leading to continued innovation across industries, from healthcare to finance and beyond. Emerging technologies like quantum computing offer future possibilities, further enhancing the capabilities of big data and AI. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.